Sisticon are experts in producing world-leading logistics software. The tool suite includes Simlox, a simulation tool that employs Monte Carlo discrete event simulation techniques. By introducing the time dimension and random events, the results provide an appreciation of risk over time, meaning the user can determine the likely outcomes of a given scenario, resulting in a much better understanding of the problem and the relationships within it. The input data in Simlox is very similar to that described for Opus 10. Indeed, all the equipment breakdown structure, logistics support organisation and recovery data are specified in exactly the same way. The only data that is not used is the cost data. For details of how these are defined, see the Opus 10 input data demonstration. This demonstration describes the aspects of the Simlox input file that differ to Opus 10. Although some more advanced features are mentioned, it focuses on defining a fairly basic model. Because of the relationship between Opus 10 and Simlox, it is usual to start a Simlox model by importing directly from Opus 10, but this is not compulsory. Models can be defined from scratch without the use of any external tools. Simlox will typically be used to analyse the effectiveness of a spares mix within a given support organisation. Whilst Opus 10 assumes constant use over time, in Simlox the user defines a discrete operating profile, which can vary over time. This is done by specifying mission types in the mission type table. These missions describe how individual systems will operate when called upon. Missions can be of three types. First, fixed. In this scenario, the mission will start at a given time, operate for a specified period, subject to failures, and terminate when complete or a critical failure is encountered. An example would be a simple aircraft sortie. The second is regenerative. In this scenario, a mission will be activated at a given time and operate for a given period. Systems will automatically be dispatched in order to maintain the required quantity on station. It effectively executes several fixed missions to meet the overall mission duration. Failures will result in the automatic dispatch of replacement systems when required and available. The aim is to maximise time on station. An example might be a maritime patrol requirement. The third type is continuous. In this scenario, the mission starts at a specified time and completes after a specified duration. If a system fails, another can take over, or the failed system can be repaired, resulting in lost mission time. But the mission still continues. An example might be a submarine operation. In all mission types, a portion of the mission time can be declared as time to get on task and a time to return from task. In addition, other more advanced features can be implemented, such as adjustments to the system failure rates for specific missions and mission preparation time. In order to activate missions, Simlox uses operational profiles. These are declared in the operational profile table. Declared profiles can include either mission types or other profiles. The aim being to generate a single profile that describes a unit's operating scenario throughout the simulation period. These profiles are exceptionally flexible and allow any number of missions and mission types to be activated in any sequence at any time interval. Profiles can be viewed using the Profile Viewer, which shows the profiles in a graphical format. This viewer can also be used to view transport and shift profiles. Both transport and shift profiles are specified in a similar way to the operational profiles. The former describing when transport links between sites are available, and the type of demand profile that is in use at specific points during the simulation. And the latter is used to describe when resources, discussed later, are or are not available, again at specific points during the simulation. Once a profile or profiles have been generated, they are allocated to each unit in the unit table. In Simlox, the stations, as described in Opus 10, will be used to home the spares and resources. But to make the deployment of systems more flexible, an additional position in the support organisation is added. These are called units and are supported directly by a station. Typically, a unit will operate only one system type, but a station may support many units. The unit table describes the relationship between units and stations, whilst the unit system table describes the deployment of systems. The allocation of profiles to a unit tasks the systems at that unit during the simulation. However, it is possible to task alternative units or systems if the one required is not available. The number of systems declared in the unit system table will typically be the starting quantity. Because in Simlox it is possible to move systems between units, as well as into and out of the simulation. This is in addition to the removal of systems due to attrition, which can be defined in the mission damage table. Further, both resources and spare items can also be transferred. So using the system, item or resource transfer tables activates these transfers. Item transfer is in addition to the normal activity for moving them around the organisation for recovery and demand satisfaction. All that is left is to set some control parameters, and this is done in the control parameters table. Note that due to the nature of simulation, it's necessary to carry out more than one iteration in order to obtain sensible results. Simlox allows the user to specify how frequently results are collected and during which parts of the simulation. The results are averaged over the result collection interval and over all iterations. Other limitations can also be set. Like other SystemCon tools, the model can be tested at any time and errors identified. This testing is also carried out when the model is executed. The remainder of this demonstration discusses some, but not all, of the more advanced Simlox features. It is possible, by using the snapshot results table, to collect results averaged across the iterations, but not the collection period, at specific points during the simulation. The results are covered in more detail in a separate demonstration. Items will be deemed to have failed as a result of random activity, within the mean failure rate for each item. The results of these random failures is that items need to be replaced in order to recover failed systems. These failures can then be used to determine resource requirements, resources being anything defined by the user necessary to repair entities within the simulation. In addition, resources may also be required to prepare or recover systems before or after a mission. Resources are declared through the resource and resource deployment tables. In addition, their availability can be controlled by using the Simlox shift profiles. The need for resources is controlled by allocating them to tasks, which are themselves defined in the tasks table. Each task is allocated to a maintenance event by using the system or item repair, item replacement or PM tables. In addition, they may also be allocated to the mission preparation and turnaround tables. Tasks may also be broken down further into subtasks, with each subtask being allocated a different resource. Finally, systems and items can also incur preventative maintenance. This is defined through a series of forms starting with the System PM table. PM activity can be defined by specifying a period of calendar hours, operating hours or missions, and can involve the removal of items from the system and items from parent items. Other features not covered in this demonstration include user-defined item damage, system configuration changes, item criticality and item criticality by mission, the ability to track individual item types, lateral support features, remote system repair, different time distributions, and robbing. Simlox can be used to analyse complex relationships not possible in tools such as Opus 10. It can assist the analyst in determining the effectiveness of a system and its support organisations over time, given a varying usage profile and many other limiting features. It's important to note that this is merely an overview of the model, and many features have not been covered. For more information about our tools, please select another demonstration. Or for more detailed information about our products, please contact us or visit our website at www.sisticon.co.uk.